Newton's first law states that objects in motion remain in motion and objects at rest remain at rest unless acted upon by an outside force. In Newton's second law, he really needed to look at the word force. If you're going to use the word force in a law, you better define what it is. Today we're going to define what a force is based on some data that we take with an experiment. Let's get started. Okay, so the first experiment I'm going to run, I'm going to actually change the force that I'm pulling this car with. So to change the force, here's the setup that I got. I got a car sitting here. Instead of using a motion detector in order to do the car, I'm actually going to use what's called a smart pulley. A smart pulley uses this thing called a photogate. A photogate's got a little light beam that goes between the things here. And then as the pulley here rotates, the little pegs on the inside, the spokes, break the beam. And our software actually knows the length of the width of those spikes, so it is able to calculate the speed every, 30th of a second or something. So I have a car here. I'm going to run this over the smart pulley. The smart pulley is going to give me a velocity versus time graph on here. So all I got to do is I got to change the force that I'm pulling the car. Now it's very important that I keep all the other variables consistent, which means I want the mass of the system to be consistent. So you got to think about everything that's moving. I've got the force that's being pulled down here. I got a half a Newton pulley hanger here that I'm going to start putting some other Newtons on. That's moving. The rope is moving. The car is also moving. So if I'm going to continue to put mass or weight down there to pull, I need to keep that whole mass of the system the same. So I got to start with some of these on the car. Since I'm going to do 5 trials, I'm going to put 4 of those on the car. That way I can move it from the car down there and the mass of the system remains the same. So here we go. Run number 1 looks like this. All right, and I got a really good velocity versus time graph, which I can now find the acceleration of the car. I'm going to then take one of these off of here, put it down here so that I can drop more weight, and I'm going to continue with my trials. I'll have the data ready for you. All right, in this second experiment, what I want to do is I want to change the mass of the system. I'm going to leave the force the same. So every time, I'm going to drop 2 newtons down there. All right? So now if I'm going to change the mass of the system, I'm going to start with the car just by itself. Then I'm going to start increasing the mass. Now if I put 100 grams on here, is that really changing the mass of the system? The car itself is 1.428 kilograms. So if I just put 100 grams on here, and now it's 1.528 kilograms, is that really changing the mass? Probably not. I'm going to actually start putting different kilogram weights on this car until we can get a pretty massive system here. Okay? So that's the goal here. The first time I'm going to drop it, I'm going to go to the car by itself. The second time I'm going to drop it, I'm going to put a kilogram on here. Then I'm going to put 2 kilograms. And then I'm going to put 3. Then I'm going to put 4. So we're going to look at the entire mass of the system and how that changes and what happens to the acceleration.